Hi guys, welcome to the Maths classroom, and now we're going to look at another little baby from 2003 S1Q9, another projectile question. So it says a particle is projected with speed v at an angle theta above the horizontal. The particle passes through the point P, which is a horizontal distance d and a vertical distance h from the point of projection. So as usual, we draw the diagram first. But it has two situations. Maybe the P is here and maybe the P is here. Different projecting angle. Yeah, and it says the coordinate of P is dh. Right. So yeah, we plug in first. We know sy equals to tangent theta sx minus g over 2u squared 6 theta squared sx squared. So h equals to d tangent theta minus d squared. So and it says let t equals to tangent theta and k equals to this. So when t equals to tangent theta, what we get is h equals to dt minus because watch out here, 6 theta squared equals to 1 plus tangent theta squared. So now we get this. Yeah, and squared, and we rearrange the equation quickly. It equals to oh, this is so annoying. I do not like this. And it says k equals to v squared over gd. So why don't we just divide gd on both sides? gd minus d minus dt squared. So we will get 2kh equals to 2k dt minus d minus dt squared, and we get dt squared minus 2k dt plus 2kh plus d equals to 0. And we divide by d. T squared minus 2kt plus 2kh over d plus 1 equals to 0. That's exactly what we need. So the first one is sorted. Okay, keep going. And it says show that if kd is greater than h, if kd is greater than h plus square root h squared plus d squared, there are two distinct possible angles of projection. So whenever we see this kind of, it says two distinct possible blah blah blah, what must come out of your mind is that it might have something to do with the quadratic equations, and luckily we have it here. Perfect quadratic equation. T squared minus 2kt plus 1 equals to 0. If we want two distinct possible angles, which means we must see the delta must be greater than 0. Yeah, so 4k squared minus 4 times 2k hd plus 1 have to be bigger than 0. Rearrange, simplify, equals 2. There we go. Let's check it again. B squared minus 4ac. Yeah, that's right. And 8h over d times k minus 4. Yeah, right. Okay, so yeah, this is another quadratic equation, and it says it has to be bigger than 0. So we want to find its root first. So we want to find its root first. So the k will equal to and we get whatever. So currently what we need is k is less than or k is bigger than. So but we know that because k equals to v squared over gd, which means k must be bigger than 0. So only thing is that works is k is bigger than h over d plus this. And because it says if kd and because kd is greater than h plus d, which means is k is bigger than which means one. So it has two distinct values. Sorted. The last question, it says let these two angles be alpha and beta. Show that. Oh, this is not going to frighten me, because now we know because we want to find this, which means we want to find this, which means we want to find this, and we can find this just through right. So because we know that equation here is correct, so on the top is 2k, and this is equals to minus d over h. And we know that because tangent pi minus arctangent dh, it equals to minus tangent arctangent dh. Equals to tangent arctangent minus dh equals to minus dh. So tangent alpha plus beta equals to to tangent arctangent minus d over h. So alpha plus beta equals to pi minus arctangent d over h. Sorted. Till next time.